Welcome back, folks, for our discussion of enzyme inhibition and allosteric control. Here are the learning outcomes for the day. We will compare and contrast Km and a new variable, Ki. We will be able to draw line-revert curves for 3 different types of inhibition: competitive, uncompetitive, and mixed. We will understand kind of conceptually why either Km and or Vmax is changing for each type of inhibitor. And I'll talk about 2 specific subtypes that I want you to know, in particular product inhibition, but also pure non-competitive inhibition. And finally, we will define allosteric control and link this idea to the types of inhibitors we learn about. Our Meet a Scientist moment of the day is Julia Serrano. She is a scientist and an activist, and she is also trans. She studied the physical development of fruit flies at UC Berkeley as a part of her thesis there, and she found a gene that controls the size of fruit flies. And I love discussing Drosophila because scientists always choose the best names for different genes, and she named hers bite size. And so when we talk about inhibition today, I really also want us to think more broadly about modulation of enzyme activity. So we can think about inhibition. Inhibition is what happens when a molecule either increases an enzyme's Km, so binding gets worse, or it decreases the Vmax. Again, the chemistry gets worse. This is most inhibitors. Inactivation is a specific type of inhibition where the molecule kind of irreversibly reduces the activity of the enzyme, either by binding super tightly or covalently, although this is rare. Finally, we'll discuss activation, and this is when a molecule either decreases an enzyme's Km, so binding gets better, or increases Vmax, chemistry gets better. And over the course of this semester, when we talk about inhibition and activation, you might see pathways drawn out like this. So you have the reaction scheme of substrates being turned into product by the enzyme on top. An inhibitor will point to the enzyme, but will have this kind of blunt-ended arrow. In contrast, an activator will again point at the enzyme, but will be just a regular headed arrow. Then finally, to wrap up this video, folks, I want to introduce this new idea, Ki, even though we won't talk about it in much detail in the class. It is good for us to be aware that it exists. And Ki is not so different from Km. Km is the binding constant of enzyme for substrate. Ki is the inhibition constant, the dissociation constant of the enzyme for the inhibitor. So you can think about it as how much affinities does the enzyme have for its inhibitor, not substrate, but inhibitor. And similarly to Km, it is the concentration of the enzyme required to produce half maximal inhibition. Next up, folks, let's move on to talking about the 3 main types of inhibition.